I tend to think of beginnings like tributaries of a river. What does it mean to speak of the headwaters of a river? You know, you follow it upstream, there's a branch, and you sort of take your choice, and you may follow the bigger one and up and up. Any river has thousands or maybe even millions of tributaries if you count them all. And finally, you sort of pick one and say, there's the beginning. Well, McDonald had two principal headwaters, and they each began about 200 years ago as little rivulets. And the first one is the stream that led to J McDonald, a word about that. His father was a government physician to the Choctaw Indians sometime shortly after the United States got going. But when they were exiled to Oklahoma, he moved to the northeast corner of Texas around 1837. That was only a year after the Alamo and Battle of San Jacinto, 8 years before Texas became a state. So it was a pretty wild frontier at that time. But it wasn't very long after that before he had a son. This was the oldest, in fact, of his three sons, J McDonald, William J McDonald, born in December of 1844. McDonald attended a small academy in Texas, sort of roughly a high school education, private academy. He served very briefly in the Confederate Army. Of course, it was hard to make a living of any kind after the war, so he took the path maybe of least resistance, I don't know, apprenticed in a law office. Before long, he had learned enough, a very bright man, really was, to open his own office, and he made some money, but he was also a very shrewd businessman. And when so-called Red River land warrants fell from a nominal value down to about 10 cents worth on the dollar, he invested all of his money in buying up those warrants, and a few years later they had revived back to a dollar's worth on the dollar. So he established the basis of a considerable personal fortune at that time, and he used that to open several banks. Well, the upshot was that by about 1887 he was able to move to Paris when he was 43 years old. Paris, Texas, that is. And in Paris, Texas, he became the leading banker. He never married, but he did become one of the really genuinely best educated men in the state, self-educated. He had a wonderful library with deeply thumbed books, Darwin, Huxley, things like this. He was self-educated in philosophy, history, religion. He had hobbies, very active in zoology and geology and botany and astronomy. He may well have been the first person to own a serious telescope in Texas. He bought one somewhere, I guess, around 1890 or 1900. So he was an unusual individual. By the time of his death, at 81 years of age in 1926, he was quite wealthy. And his last will left $15,000 to each of 8 closest relatives. They were nephews and nieces, basically, of his brothers. And that $15,000 you have to multiply by, I would guess, probably 15 in buying power to get what it's worth today. So roughly speaking, he left each of his relatives about $200,000. They, of course, were not satisfied with that, so they contested the will on the grounds that he must have been prima facie insane to leave his money to astronomy. It was fought through a whole series of court actions, the relatives trying to get the rest of the more than $1 million that he had left to the university there to build the observatory. And the relatives kept losing, but they kept bringing the arguments up in different ways. So the university, seeing the whole thing gradually fading away in lawyers' fees, finally settled out of court and gave the relatives $250,000, about twice what McDonald had left them. And after the lawyers' fees and all were paid, the university got a bit over $800,000. And that then raised a problem. Why a problem? Well, there were no astronomers in Texas. Well, not quite. There was one astronomer in Texas. His name was Benedict. He was dean of the college at that time. And he had been teaching astronomy in very early years at the University of Texas, but had given it up for administration long before. Some of you, a few of you may know the name Oscar Monning. He was probably the country's leading amateur meteoricist, really a professional, although he ran a large department store in Fort Worth, Texas. And Monning told me a few years ago that when he was in Texas in 1926, he signed up for the astronomy course taught by Dean Benedict. And 2 or 3 others signed up for it too, and they went to class the first day, and no professor showed, so they wondered, but they all went home. Came to class the next day, no professor showed, so they went to the dean's office, and he looked at them in astonishment and said, "What? You signed up for that course? I didn't know it was still in the catalog. I haven't given it for years, and I never intend to give it again." So anyway, this was the one astronomer in Texas. Well, he was a good man, and very shortly thereafter he became president of the university. And he also had a pretty good idea of what to do with the money, namely, you could build an observatory with it. But as one of our speakers today commented earlier, in those days, Dan Popper told us, reminded us, there was no science foundation, no NASA. What he didn't say was there was no state money for research, and professors were expected to profess. I don't know exactly, but I imagine the teaching load was probably 3 or 4 courses per semester, maybe more. No time, no money for research, and no astronomers in Texas, so what to do? Well, you could build an observatory, but unless you had the money to endow it, nothing was going to happen. So you didn't have money to do both, though, with only $800,000 if you wanted to build a big one. So anyway, the money was put in the bank in the hopes that it would someday add up to enough to simultaneously build an observatory and endow it. And at the 2–3% interest per year of those days, this would have taken a little while. Now, we've taken one of the rivulets down to the point where it's beginning to become a good-sized stream. Let's go to the headwaters of the other branch. And this is almost simultaneous, about 200 years ago. It will lead to this gentleman, but 200 years ago, about the time McDonald's father was born, a man named Vilhelm Struga. His dates were 1793 to 1864, so he overlapped almost perfectly with the first chunk of U.S. history. He left Hamburg to escape Napoleon's draft during the Napoleonic Wars. He settled in Dorpat, which is now Estonia, where there was a little observatory. He became an astronomer, and a very good one. So Vilhelm Struga was hired by the Tsar of the Russias, all the Russias, to build the world's best observatory near St. Petersburg, now Leningrad. And, remarkable chunk of history, Vilhelm Struga founded the Pulkova Observatory in 1839, exactly 150 years ago. So Pulkova is celebrating its 150th anniversary while we are celebrating our 50th, and we're both commemorating Struvas as our founders. An unlikely coincidence. Chip Arp, take note. At any rate, that's an in-joke for the astronomers. At any rate, Vilhelm Struga became leading astronomer of his generation. He published some 272 papers. He was one of the first 3 to measure stellar parallax. He earned, I should say, the gold medal of the Royal Astronomical Society in 1826, even before founding Pulkova. And this career of tremendous accomplishment he did in addition to, perhaps his greatest accomplishment, he fathered 18 children. And one of those 18, Otto Wilhelm, became director in his turn, also a great astronomer, and gold medal of the Royal Astronomical Society in 1850. And 2 of Otto Wilhelm's sons became great astronomers. Hermann received the gold medal of the Royal Astronomical Society in 1803. That's the 3rd generation now. And Ludwig, who was the father of this man, became director of the Kharkov Observatory, and Otto himself here was destined for the gold medal in 1944. 4 generations for the greatest award, highest award in all of astronomy. Nothing like that, of course, has ever occurred before, or probably ever will again in astronomy, or even, I think, in any other field of science. There are some that have 2 or 3 generations. Bernoulli's music has, I think, 3 generations of Bach's. Is it 4, 3 or 4? But it's rare. Remarkable dynasty, remarkable people. Now, while we have Otto's picture on the screen, I think we ought to round out some words to put some flesh and blood into that picture. Otto was born in 1897 in Kharkov. He grew up in a Tolstoy-like estate of minor Russian nobility, really. In 1914, at age 17, he entered the Kharkov University to study astronomy and math. But of course, the war was starting just about, must have been the week he entered the university. In 1916, at age 19, he left the university to enlist in the Tsarist army. He was made an artillery officer on the Turkish front, and shortly thereafter, a year and a half later, March 1918, the Treaty of Brest-Litovsk ended the war for Russia, so Struve promptly went back to the university. In only a year, he finished his physics and astronomy program, math and astronomy. He graduated in 1919, and immediately after graduation, in June, he chose to enlist in the White Army, the Tsarist army, effectively, although the Tsar, I think, had been killed, the White Army of General Denikin, and was with the cavalry there in order to try to get a more democratic government than the Bolshevik one, which of course took over. He was wounded in the next month, but survived that. And over the following year, he also survived diphtheria, scarlet fever, typhoid fever, and rheumatic fever. Otto Struve was a tough customer. But in November 1920, he and the soldiers in the army, General Wrangel's army by that time, were driven down into the Crimea, and he joined the last 150,000 refugees who left the Crimea on a ship, on many, many ships headed for Turkey. There, of course, it was one of the refugee situations not too different from what we see around the world today. He lived out of soup kitchens and for a while earned his living as a lumberjack. But the name Struve, as you can imagine, was fairly well known. And his existence was known. In fact, there apparently had been some correspondence with an astronomer in Germany out of Turkey. So in any event, the director of Yerkes Observatory of the University of Chicago, Frost, wanted to make contact and worked very hard to do this, and finally managed to get a letter through to Struve, through the YMCA, I think, in Constantinople. And in effect it said, you telegraph me your address and I will telegraph you money to come. So it was done. By 1921, Struve had reached Chicago in October. And now, only 2 years later, he had his PhD in astronomy. And you know, he was overcoming the language barrier, the health recovery problems, and the broken up years of education. Extraordinary. And it happened, of course, I think, because of a certain amount of hard work, because he began, for example, publishing that very year that he earned his PhD, and by the time he died, of a relatively early age, he was 66, he had published more than 900 papers in astronomy, which may be a world's record. It's certainly close to it for astronomy at any rate. And in the light of his obvious stellar abilities and achievements, and by 1932 he had become director of Yerkes Observatory. Now, there was a foretelling of this 4 generations earlier. I'm going to give you a quotation from a letter. It says, quote, "The Struves cannot live happily without unceasing work, since from earliest youth we have been persuaded that it is the most useful and the best seasoning of human life." That's from a letter written by great-grandfather Vilhelm, and apparently it continued. Well, okay, the streams have merged now, and we're into the full beginning of McDonald Observatory. Struve, possibly through an astronomer Van Biesbroek there, heard of this McDonald bequest sitting in the bank in Texas. Now, Chicago at that time, 1932, was well stocked with outstanding astronomers. I don't know the exact story. I presume that, of course, this was deep in the Depression, but Rockefeller still had money, and Rockefeller was funding Chicago rather lavishly at that period. So it's my understanding that it was possible for Chicago to be hiring very good people at a reasonable salary at a time when many other places could not. That may have had something to do with it, but also there were some very wise people making very good choices. So the net result was that Chicago was well stocked with outstanding astronomical brains. But what they really needed was a telescope that could compete with the 100-inch at Mount Wilson, then the biggest in the world. In other words, a great modern reflector in a good site. Now, Struve said, great, Texas has the money, Chicago has the brains, let's put them together. And it was proposed, I understand, in a telephone call after Struve persuaded Hutchins, President Hutchins, the boy wonder president of Chicago, that this should be tried. One version of the story is that Hutchins picked up the long-distance phone and called President Benedict by that time at Texas, and they agreed in 10 minutes over the outline of it. Well, it took a while to sell. In fact, it took about a year to sell the regents of the university on this, but they finally did go along with it. I'm not sure you can read that from the back. This is a quotation of Struve's. "I met with the regents of the university and found that they had no objection to a foreign-born director. One of them even expressed a preference for a foreigner rather than a Yankee." I wanted to show you that partly because I'm deeply grateful that 30 years later, the regents had forgotten that prejudice. Mein accent is not so good. Well, but if we're going to talk about that, the Ohio River Island on which I was born was only 9 miles north of the Mason-Dixon line, so you know, I can take me south if you want. Anyhow, let's see, where are we? Yeah. The idea then was to get a union formed with Chicago brains and Texas money. And once it was agreed in 1932 that there would be a treaty signed in 1933 between the two universities to run for 30 years, then the squadrons got to work. And Struve wasted no time. He had sent Elvey and Malin, astronomer who later taught for many years in New England, as I recall, chose the Davis Mountains area after looking through a good part of the Southwest. I think they went to Arizona and New Mexico at least. And knowing it was Texas money may have had something to do with the Davis Mountains, but also it's a very fine area here. So at any rate, Van Biesbroek, the astronomer mentioned before, to be mentioned again a time or two, did the detailed work. And he and Otto Struga chose Mount Locke on the U Up and Down Ranch owned by the McIvers. And at that time, Violet Locke McIver operated this ranch. She was a very good-hearted woman and chose to give a mountain, where the observatory now is, to for the observatory to be built, gave it to the university, so that was named Mount Locke. And an adjoining piece of land that rounded it out from the Folks Ranch was also donated, so that came there too, and our secondary mountain is Mount Folks. This is George van Biesbroek, the Belgian astronomer, the man who picked the site. Van Biesbroek's knoll up there, Van Biesbroek's knob, which he used to walk to, I'm told, almost every day when he was at McDonald. But that magnificent vehicle, and eat your heart out, McDonald physical plant people, that was the first station wagon owned by the observatory, and it says University of Texas McDonald Observatory. You probably can't read it. Struve looked around as to who might well build a telescope with the now $800,000 in his pocket, and he chose the Warner and Swasey company, made machine tools in Cleveland, Ohio, and their architect drew this, and I think you can almost see it. It came out just the way the observatory did, except for one thing. The architect had a lone star over the door, and that never materialized, and we're going to have to do something about that. Meanwhile, though, construction got underway very promptly. It didn't take them long. The contract was let in 1933 to build the dome, and already construction was well underway in the summer of '34. It was finished in October 1934. That's the real dome, not the architect's. And they also were beavering away on the telescope back in the shops in Warner and Swasey. And it was discovered a good many years ago that when you have a telescope on a remote site and the bolt holes don't fit, it's a little bit awkward. So there's been a tradition for many years. You assemble your telescope in the factory before you ship it. So here is the 82-inch telescope, the world's second largest telescope to be in the Warner and Swasey shops. And trundling slowly up the mountain, I don't know whether you noticed, but in those days, even now, some big trucks sort of open their sides to get some air, get a puff of air as they come up that steepest paved road in Texas, carrying their heavy loads. And the telescope was duly erected and ready for dedication already by the end of 1936. How come the dedication came in 1939? Thereby hangs the tale. And the tale is the optics. Now, you're going to hear more about the optics in just a couple of minutes, but the basic problem was that the optician doing the optical work had never done really large mirrors, and curiously, it appears that he didn't know how to finish the job. He knew how to get it close, but then as he would try to make a correction, he would grossly overshoot, and then he would have to come back and just back and forth, and the process didn't converge. Till finally Struve took a hand in it after several years of intensely growing frustration, and finally was able to bring things to a conclusion, but a few more words about that later. So at any rate, the telescope had to wait a couple of years to get the mirror. In fact, 2.5 years, and then everything for shakedown. Finally, in May of '39, the telescope was dedicated. Now, at this point, I want to take a digression back to some personal things, because Struve had the perfectly correct idea that if you're going to build a big observatory, you need to have somebody keeping an eye on things. So he got a... Frank, did you have your PhD yet? Yes or no? You did have it, okay. Just completed. Well, a fresh young PhD was assigned as his postdoctoral project to go down and oversee the construction of McDonald Observatory. Franklin Roche.
I came here in the summer of 1934. That's about 55 years ago. I came here from Chicago, from the Yerkes Observatory, to act as a kind of liaison between the University of Chicago, the University of Texas, and the contractor, Warner and Swasey, who was working on the building. This building was under construction at that time. In 1934, we were in the very depths of the terrible Depression. The Depression was keeping the spirits of many people down, and it's rather interesting to me to realize that Mr. Struve, Otto Struga, had the enthusiasm to get us involved in a major enterprise. And believe me, it took some enthusiasm, it took some nerve to start on a big project like the McDonald Observatory when the general conditions in the country were rather desperate. Also, in 1934, the plains country of our United States was having a very bad drought. And I can remember standing on Mount Locke and looking to the north and seeing a great black cloud of dust working its way here, the dust having accumulated from the farmers' the farm country to the north of us. In the group that came with me was my wife Eloise, my young son, about 4 years old, John, my brother, Richard, and an engineer, Mr. Theodore Emiga. This was the group that started out here at the observatory. The house that we lived in was not at the moment completed, so we had to start living in Fort Davis, and we drove back and forth to work up here. When the house was completed, of course, we moved up. There was no electricity, there was no running water, so we had to bring the water up every day and use ordinary lamps to light the things at night. At that time, when I first arrived, I wasn't just doing liaison work, I was also doing a very interesting research program. Professor Struga, whose name will always be remembered as the spirit who founded this scientific work here, Professor Struve was very insistent upon continuing with scientific work immediately, even though we didn't have a big telescope. So I brought with me from the University of Chicago, from the Yerkes Observatory, a rather small telescope, but one in which I could cover the whole sky in the course of about a half an hour or so. The telescope had for its principal active member what we call then a photoelectric cell. Photoelectric cells have been much, much improved since that time. And the photoelectric cell recorded the brightness of the sky as we moved around from north to east to south to west, and then we moved up a little higher and moved around again, and so on until we had covered the sky. In the course of the first year here, we accumulated a great deal of data, and it took us about another year to analyze the data. When we say analyze the data, you have to realize that we didn't have the modern computing machines at all. We had slide rules. We had a calculating machine which would multiply and divide, add and subtract, but a far cry from the kind of computing equipment which we all have on our desks at this time. And we had to convert the direction in which we looked in the sky to various astronomical coordinates, because the light on the sky depends upon where we are with respect to the various coordinates, the various circles in the sky. McDonald Observatory, starting in that very elementary way with a very small telescope, has graduated, of course, into fundamental, very large, and very important research.
So, the mountain began to become very slightly populated. And so it came time for a dedication. And again, just 100 years after Pulkova, the fourth generation Struve had his observatory. Now, something strange happened. I had been at Texas only 3 or 4 years when a student, when I was out of the office, came into the office and gave to the secretary at the desk something. He said, "I found this lying in the street." It didn't have the case at that time. What he found lying in the street in a beat-up, wrecked old paper envelope was this item. And you can't read it from where you are, but it says Texas State Network. Start inside, 33 1/3 RPM. Produced for University of Texas. Subject, McDonald Observatory, BDCS, which I guess means broadcast. Then date May 5, 1939, number 2. Number 1, never found. Probably this blew off a dump truck going off to the trash, I suppose. Otherwise, how would the student find it lying in the street with tire marks on the paper cover? I'm going to take you back 50 years ago to the first dedication of McDonald Observatory. And the record is of extraordinarily good quality and is entirely self-explanatory. There are the people speaking on the record for broadcast later around the state of Texas by electrical transcription, where these records were circulated around to the stations, were clearly people not very used to public speaking. There are some wonderful slips of the tongue, such as the Warner and Swayze meat factory. And speaking of the dedication as a service, almost like a burial, the mirror finding its final resting place. Well, you'll get that. Excuse me. Let's go with the tape.
Mr. Charles J. Stillwell, president of Warner and Swayze of Cleveland, manufacture precision meat machine tools. And Dr. Stillwell is going to tell you a little bit about some of the experiences that he had and the members of his staff had in the building of this great new instrument. A telescope is a great instrument, and yet in Mr. Stillwell's experience, the building of telescopes is somewhat of a very pleasant sideline, almost a hobby. Mr. Stillwell, what about this great instrument? Tell us a little bit of some of the things that you did to create it and make it take its place in the astronomical world.
Well, I suppose, Mr. Davis, it would take the rest of the afternoon to tell you all of the interesting experiences that we've had. Way back in 1933, Dr. Benedict, then president of the University of Texas, called us in for the purpose of designing and building this great instrument which is today being dedicated. If I were to relate to you from what followed that conference in the way of interesting experiences, I suppose one of them would be the first trip that some of us made out to this mountain in the Davis Mountains. It was a new experience to any of us, and with a friend from Fort Davis, we first climbed this mountain afoot before the highway was put in for an exploratory trip and observations preparatory to putting in the massive concrete foundations. But I shan't go on with all the detail that followed. I suppose one of the most interesting, the very most interesting process was the building of the great 82-inch mirror. That mirror was first cast in Corning, New York by the Corning Glass Works. And it may be interesting to you, Mr. Davis, to know that the material from which that mirror is cast is exactly the same thing as your folks use at home in the kitchen in the glassware that they use for cooking, Pyrex glass. That same glass is used in this mirror, and for the very same reason. Pyrex can be used for cooking because it doesn't expand and contract so rapidly with heat and cold. And for the same reason, this mirror will hold its shape made from Pyrex and will not be distorted by the heat of the noon sun on this mountain and the cold of the evenings that we get out here in the Davis Mountains. That great disc of glass, 82 inches in diameter and weighing something over 3 tons, was then transported to our plant at the Warner and Swayze Company in Cleveland, and for 4 long years it was ground and polished on a massive machine which was built for the purpose. This great machine with a revolving table has an oscillating arm, and on this arm is borne a tool shaped to perform the ultimate curve which we want to achieve in the mirror. After we had worked something more than 18 months to rough grind the back, the sides, the edges of the mirror, and to rough grind the face, then came a long drawn-out polishing process. This was all done under the supervision of Mr. Lundeen, who is here today attending this dedicatory exercise. After the mirror had been completed to the point of hand figuring, Mr. Lundeen cut down the polishing time to as low as 15 or 20 minutes a day, because even that amount of rubbing with the abrasive being used would create sufficient heat to distort that massive piece of glass. Finally, The mirror, as many of you listeners may know, was transported here in a carefully packed case on an express car, unloaded at Alpine, and drawn up on the mountain one afternoon and hoisted in to its place where it now resides in the great telescope. I suppose to me, although I had nothing to do with it personally, I suppose to me, the figuring of that great mirror and its transportation, finally put it in its resting place here in this great telescope, was the most thrilling of all the experiences we've had in building this great instrument.
Well, that's very interesting, Mr. Stilwell. Dr. Otto Struga is the director of McDonald Observatory. He is the man who will direct this extremely interesting and efficient staff of astronomers here up on Mount Locke in the use of this great instrument to add to astronomical knowledge. I wanted to ask Dr. Struve, what do you propose to do with this giant among telescopes now that you have it? Won't you tell us a little bit about your plans for observing and some of the things you hope to do with it?
We propose to observe stars as individual objects, not as material for statistical studies. We want to find out why it is that matter in the universe is concentrated in essentially two types of form. There are the ordinary stars, like our own sun, and it is one of the most interesting and exciting results of modern research that the stars never exceed about 100 times the mass of the sun, and very few are smaller than 1/10 of the sun. The other form of matter is finely divided dust and gas, and we at the McDonald Observatory hope to find out why it is that only these two forms have been created in our universe. In order to solve this problem and similar related problems, for example, the problem of the generation of energy by the stars, we have made this telescope as efficient as we knew how to serve as a photographic and spectrographic instrument. The energies of the stars surpass all imagination. Our sun is a dwarf star, yet it creates an amount of energy so large that no appreciable change has been observed over the century or century and a half that accurate radiometric observations have been in progress.
Well, that began the history of McDonald Observatory. And first we have the Chicago years, because there were then about 26 actual years in the contract, 33, 24 years, I guess. It was a galaxy of talent then, and growing through the 40s into what I think by the mid to late 40s was certainly the preeminent astronomy program in the world. And Struve himself could practically fill the astrophysical journal single-handed, and a fair proportion of the papers that came out in APJ in those days were out of the Chicago group, the Yerkes-McDonald group. Swings, of course, worked very actively with Struve then before he returned to Europe, and came frequently back to work with Struve. Kuiper, I said I would mention a little more about. He was not only one of the leading astronomers of the Yerkes group, but the man who, in addition to a lot of early work on stars, turned his attention to the solar system and, in effect, revived that field. Before Kuiper and, to be sure, Whipple at Harvard, I think astronomers who did solar system work became pariahs very rapidly. Somehow the professional world thought the solar system was strictly for amateurs, and things aren't far enough away to be interesting unless they're at least a few light years away or something. Some elements of that may persist in the field today, but Kuiper went a long way single-handed to make solar system respectable for professional astronomy. And Bill Morgan, I mentioned. Remarkable man. By the way, Kuiper became director after Struve, and Morgan also, and Stromgren mentioned. Bill Morgan, for the benefit of those of you who aren't astronomers, set up the the improved classification system of stars so that an astronomer can spread the light of a star out in a little spectrum, easy to do, and look at it and identify the star, and not only that, tell very important things about the star, in particular its absolute brightness, its candle power, how much energy it's putting out. Really a marvelous piece of work that Morgan did with associates. In fact, he is still doing it. So it was really a mecca for world astronomy in that period. But something happened. Struve left in 1949. And I've never fully understood the reasons. I've heard various stories, and I think perhaps the best capsule summary that I've been able to get, and this is me talking, I don't know if it's the truth, but I think basically Struve was raised in a very authoritarian tradition, and he applied that authoritarian tradition to the bright young astronomers at Chicago when they came back from war work and so on, and they didn't like it. Broadly speaking, European director tells people what to do, and American director helps people to do what they want to do. I think that's a fairly accurate differentiation. And Struve was a European director, although a magnificent astronomer, and while he was there, he provided what, now speaking to the astronomers, is what holds in, some types of interstellar clouds together, you know, surrounding pressure in some sense. But when he left, then the analogy, I think, would switch to a large and complex nucleus consisting only of protons, no neutrons. So it fisses. Anyway, whatever actually happened, sadly, the things went very rapidly downhill after Struve left at Chicago, and by a decade later, most of the really exciting people had left, and sure, it remained a strong department, and by the way, it's been building back up greatly in recent years, but by the late 50s, things were very different. Now, one strong man had been added to the staff, Al Hiltner, actually in the 40s. I don't have a picture of him, but I do happen to have this picture when he was installing the spectrograph at the 82-inch telescope, the world's first rotary coup d'etat, so in just a moment you could switch from one dispersion to another. It's still there, still in active use on many a night. In fact, several of the results that were reported today in some of the earlier papers were obtained with this spectrograph. And this is the superintendent of the observatory at the time, Marlon Krebs, at the installation there. So anyway, Al Hiltner did help to build up things at McDonald, and indeed he added the 36-inch telescope. This is probably the lowest cost major telescope in the world. Buller and Chivens, who are now the Cadillac or the Rolls-Royce of telescope makers, they'd build you one like this today for something over $1 million, I suppose. They charged the observatory, got your seatbelts fastened, $30,000 for this telescope. And it's a wonderful instrument. The optics were actually made mainly by amateurs in Chicago, I'm told, so it cost very little. The building was made of stone quarried by the staff of the observatory, and they fabricated the dome on site. The rising platform is a relic bought for a few bucks from a junkyard for a hoist that puts cars up in a garage for lubrication. And it's been a tremendously productive instrument. And lest you think it's a little baby, being only 36-inch, it's only in the last few years that the two most populous countries in the world have had telescopes slightly larger, 40-inch instead of 36. India and China each got their first telescope of that size only in the last few years. So from that point of view, this is a big boy, and also remains a very productive telescope at McDonald after its installation, goodness, 57, more than 40 years ago. Well, okay, now we come to the end of the Chicago years at McDonald, although Chicago continued right up to the present day to make use of McDonald and still is a very welcome guest cooperative observer at the observatory. But the end of the Chicago years of running the observatory came in 1963. And at that time, the observatory consisted of the 82-inch telescope, the 36-inch telescope, and a couple of houses dotted around on the mountaintop, and that was about it. And it had a problem. In fact, it had a very serious problem. In fact, it had two very serious problems. The first one was that for roughly the last 6 or 8 years, the authorities at Chicago had realized 30 years were coming to an end. And after that, Chicago would have no guaranteed rights to the observatory, so why put Chicago money into anything there? And indeed, not a lot of Chicago money ever really had gone into the observatory. It had been mainly Texas money, and that had been building the things for Chicago use. And Texas, on the other hand, had no particular interest in the observatory because they were getting virtually no use out of it. Now, that was Texas's fault because the treaty had originally said Texas should build an astronomy program over the 30-year period of the combined operation and learn how to do this from Chicago and be prepared to take over when the 30 years was over. But up until 1959, Texas still had not hired astronomers for astronomy purposes, had hired one in mathematics. And Even in 1959, the only half-hearted step made was to hire several other astronomers in a so-called joint department with the University of Chicago, so that theoretically the appointments at Chicago were also at Texas and vice versa, and grad students could interchange between the two. Someone who was around at that time told me there was never even a lecture exchange. It was strictly a paper arrangement, but anyway, it did give the nucleus of a start of a potential astronomy program at Texas itself. But now, that's one problem. The observatory had been allowed to run very far down because Texas wouldn't put any more money into it, and Chicago was afraid to. So things were getting pretty dusty, and only 4 people were associated with the observatory by 1963. 1 superintendent and 3 other staff, a night observer, and a couple of sort of physical plant type people. At any rate, Texas took a look at that and said, my goodness, what are we going to do with this? We still don't have astronomers, seriously, and gosh, are we going to do anything? Well, as far as I know, it was Don Menzel who saved the day. He happened to have a daughter who had moved to Austin, married to a businessman, so he got down there fairly often, and he got to know the powers that were at that time. And when he heard that there was some consideration of shutting down McDonald Observatory, he hit the fan and told them that they ought to be doing just the reverse, that this could and should become the brightest star in Texas crown. So the university turned around and said, okay, we'll give it a whirl. And I agreed then to come down from Yale, where I'd been for the previous 10 years, to be the first Texas director under 5 conditions rather. I told the university that first, we should be allowed to build up to at least 12 full-time faculty members, that we should be given substantial university funds to refurbish the 82-inch, than which virtually nothing had been done with it in its first 25 years, except using it. It needed a lot of things. And that we should have support in building a substantially larger telescope, that we should be allowed to begin radio astronomy, and that we should be supported in moving into space astronomy as that became practicable. Well, there was never a written answer to these written conditions, if you will, but there was a phone call that said, yeah, we'll take it, come on. So I came, and it's been a lot of fun over the years since then. The university has given us very good support in only, well, let's see, here's where we began. Frank Edmonds, who died several years ago, was the mathematician astronomer hired in the 50s, and he came over from math to join the new astronomy department effectively. Terry Deeming came from Cambridge, England. In theory, he left after a few years and became a seismological mathematician, making about 5 times as much as we'd ever been able to pay him. Bob Tall, you'll hear more about, the great instrumentalist at Texas, and Gerard de Vaucouleurs, the great galaxy specialist. So here was our initial group in 1963. Already a couple of years later, we had grown to 8 or 9, and currently we're up to about 24 faculty in astronomy. Many of you will recognize, maybe you won't now because he has a beard, Bill Jeffries, Frank Edmonds, of course, Jim Douglas, radio astronomer who built the great Marfa Radio Observatory, Terry Deeming again, Nick Wolf went to the University of Arizona, Andy Young, now in San Diego State, Gerard de Vaucouleurs, and Charles Seeger, electronics specialist, who went out to help the SETI project, and I understand he still has some connections with that at NASA Ames. And that was our group after only a couple of years. So things did begin to sprout. The university gave us good support to build the program. And they allowed us to, in fact, gave us $100,000 to refurbish the 82-inch telescope. And a great deal was done with that. In particular, improving the access, providing a lot of storage space, building a proper air-conditioned room for the Coudet spectrograph, and then giving us the funds to improve the optics. And that was very important. Now, all of you are thinking, yeah, he got that slide in upside down. But yeah, he didn't. Because when I put this slide right side up, all the people are leaning over and you can only see their toupees. But when you look at their reflections in the mirror, you recognize. How many of you know who this is? Call it out. Plaskett, absolutely. Who's that? Lundeen, right. I don't know these guys, do you? Well, anyway, this way we can at least see who they are. And the problem is that Plaskett came as the authoritative expert to look at the mirror and say, hey, it's great, accept it. I don't know whether Struve slipped him a bribe to get the mirror out of the shop or not, but unfortunately, although Plaskett gave it a super bill of health, we know that the mirror came to McDonald with about 1.5 waves of aberration in it instead of like the 10th wave, you know, you'd like a mirror to be. And that proved to be serious. It meant that the mirror very seldom gave good images in all the first 25 years of use at McDonald. And indeed, I think it's one of the reasons why McDonald early got a reputation of having, quote, poor seeing, unquote, because The optical expert who came and really studied the situation in great detail later, Jean Tex Rose here to the right of Marlon Krebs, Superintendent Krebs, Tex Rose, told us a bit more of the story. I'll relay that very briefly to you. It's rather interesting. Tex Rose was the optician of the Paris Observatory and a true artist is the only word for it. He studied the mirror for a few weeks under all conditions and demonstrated conclusively with his photographs that the mirror did suffer from about a wave and a half of mainly spherical aberration, and that, however, under certain thermal conditions, the mirror would come to a good figure as it was warping from one phase to another as the temperature changed. And he went back and studied the Plaskett reports, and he concluded that those reports were made by Lundin bringing Plaskett into the shop at just the time that Lundin had found by experiment that in the badly temperature-controlled shop at Warner and Swayze, he could watch the mirror go from one bad figure into another bad figure and pass in between briefly about a half an hour. Pretty good figure. So at any rate, this is Tex Rose's explanation of how the mirror ever could have gotten a clean bill of health. And what he did basically was, not being able to touch up the primary, he put the compensating errors into the secondary with the negative sign. And he created a diffraction-limited telescope at both Cass and Coudet. I have a photograph that shows a double star of 7/10 of an arc-second separation Tex Rose took with the two images that far apart. And each image is essentially a diffraction-limited image. I mean, that proves the optical quality. Now, the seeing doesn't let you do that very often, but a marvelous piece of work. So anyway, that was one of the things we were able to straighten out in 1964. And we also got the support from NASA and the university to build what became the 107-inch telescope. Now, I'm going to show you just a few quick slides because very few of us have ever had the fun of building a big telescope, and it's kind of fun to watch them grow. But also, some of the most beautiful artwork in the world gets concealed and never seen again. Now, how many of you have on your campuses things that look somewhat like that, only they're usually tipped at odd angles and so on, that the art department has put up? I think this is much prettier. And one of the graduate students, in fact, took a look at this in this phase and said, that looks like a Trojan horse contemplating its tail. But anyway, it's the pier of this 107-inch telescope, 66 feet high up to there. And of course, the telescope will lie at the polar axis angle, room in here for a great Coudet spectrograph, and so on. So let's watch it go up. Bing, bing, bing. Now, what you've seen flash by, design work started in early 1965, dome completed in late 1967, no problem. The telescope, however, was not here. Dome floor waiting for telescope. What happened to telescope? Now, in the case of Yerkes, of the McDonald 82-inch, what delayed things was the mirror by 2.5 years. In our case, the mirror was ready about the time, a little later than when the dome was finished, but in our case, we had to wait for the telescope. We let the contract go to Westinghouse, which sadly chose to give us a hard time, double the price, double the time scale. It was a sad scene, but finally it got corrected by some heroic work on the part of the university officials working with the company officials. And enough said about that, except that the workmen in the shop at Westinghouse did a marvelous job. They built a great telescope. It was the management of the company that left a very, very, very great deal to be desired. At any rate, eventually, 2.5 years late, the management finished the telescope, and it began to be brought up the mountain. This was the 40-ton polar axis, and it was being pulled by 3 trucks, which stripped their gears coming up the mountain and had to put blocks under. Eventually, a bulldozer shoved the piece up the hill. Now came one of the exciting parts, because we had designed a 10-ton lifting crane into the roof of the building in order to handle the assembly of the telescope, moving a mirror for illuminizing and all that. And this is a 20-ton crane and a 40-ton polar axis. Get the numbers straight here. And I had worried a good bit about this, but Charlie Jones, the detailed design engineer of the telescope, told me something that encouraged me a great deal all the rest of my life. He said, don't worry. Airplanes are designed with a 50% safety factor in all parts over the expected maximum load. I said, 50%? Yes, 50%. And he said, cranes are designed with several folds, so don't worry, it'll work. And sure enough, it did. But we watched with great tension as that massive polar axis was squeezed and wiggled into place and hauled up the hatches and pulled up into place. Amazing men are riggers. there's a man riding up in here, and he's got an 80-foot drop if anything lets go there, but nothing went wrong. These people just moved that massive machinery around like it was eggs on a plate. Spectacular. The declination bearing and housing going into place there. And meanwhile, in fact long before that, the optics had been being prepared. Some of you may recognize David Evans here. The mirror was being done in another fashion. Goodness, we got started a little bit late, and the astronomers at least don't have anywhere else to go, so let me digress a little bit. These are interesting stories to me, maybe not to you. But some people have said, how come you designed a 107-inch telescope? Did you want to be bigger than the 100-inch at Mount Wilson or bigger than the 103-inch at the Crimea, or what? The answer is no. This telescope became 107-inch because it started out as an 80-inch. Oops, how'd that happen? Well, it's because the 82-inch telescope started out as an 80-inch, and Struve didn't like the original casting, ordered it recast, and it slumped out to 82-inch. So that's how we got an 82-inch. Then, when Kit Peak built their first big telescope, they originally told the National Science Foundation they would take after the McDonald 82-inch, but they decided to design their own, and they whispered to the optical fabricators, please make it a couple inches bigger than the 82-inch, so theirs came out 84-inch. Fine. Now, when it came time to build our 107-inch, we were going to build it very, very fast for NASA in order to do more ground-based work on planets in preparation for space missions. To do that, we wanted to take plans that pre-existed. Therefore, we said, okay, we'll copy the plans of the Kit Peak 84-inch and zip ahead and build it in 2 years. And NASA said, fine, hop to it. So we signed a contract with NASA and all the things going on in parallel and went out. And when Kit Peak tried to deliver us the plans, they found they couldn't. They were tied up in litigation. So we went back to NASA and said, we'll have to design our own. NASA says, all right, hop to it. So we did. We started designing an 84-inch. And meanwhile, we sent emissaries all over the world to find where we could get the blank quickly enough for the mirror. Well, there existed no blank of that size, and in Pyrex casting, it would take some years to make a new blank of that size, but Germany had an effective Pyrex blank of 105-inch size in the shot works. So we told NASA, okay, that exists, we'll buy that mirror, you let us upgrade the size of the telescope design, which is just barely underway. NASA says, fine, go ahead, hop to and build a 105-inch. So the design was scaled up to 105 and roared ahead. And Jean Tex Rose found time to go test the shot blank, and he found it was so full of internal strain that had it been ground, it probably would have shattered. So he says, nuh-uh, don't buy that one. So what to do? Well, like cavalry to the rescue of Fort Davis, we learned that the Corning Glass Works had just finished the ability to create large mirrors of pure fused silica, a wonderful material. How do they do it? Well, basically, they take a large furnace and they burn chemically pure carbon silicon tetrachloride and chemically pure hydrogen-oxygen flame, and they create hydrochloric acid that goes out the chimney and fertilizes the landscape, I guess, all around. And silicon dioxide, or quartz vapor, forms in the furnace, and then they refrigerate the floor of the furnace to a bitterly cold, 1,500 degrees or something like that, and on that frozen floor of the furnace condenses out the quartz vapor and builds up a layer of absolutely pure, chemically pure fused silica. And then they make great slabs of it and fuse them together and create blanks of any size. It's a wonderful process and is still in effect. They make vast quantities of this today. We were the first users of it because they could produce this mirror in a relatively few months, the blank, and they did. And it came out of the furnace 111 inches in diameter, but had to be ground down to get bricks and things out of it to 108, and then we beveled a ½ inch because we're honest. We talk about the optical diameter most people talk about, the full diameter of the mirror. And that's how it became a 107-inch reflector, and now you all know, and I'll bet none of you could repeat that story. Here's what it looks like with the many slabs in it. And side view in the Davidson Optical Shop, California. President Hackerman admiring the new mirror. And finally it got dedicated. Now, the 107-inch telescope had barely been completed. In fact, it was being dedicated almost when I got a call that there would be retroreflector carried to the moon by the Apollo astronauts, Apollo 11 in 1969, and would we allow the 107-inch telescope to be used to try to send a laser pulse to that retroreflector carried to the moon by the astronaut and put down on the surface aimed back toward the Earth? Sure. We gave it a whirl, and we succeeded very quickly after the astronauts got to the moon. And for 15 years, McDonald was the only observatory doing this on a scientific basis. We've also built a special telescope for that, so the 107 doesn't have to be used. So we have now a dedicated telescope to do the laser work, a small one. The hole that was cut out to make the cast grain hole of the 107-inch telescope obviously was aching to become a telescope in itself. So we sliced it in two and got two 30-inch mirrors, and one of them went into the laser telescope you saw a minute ago, and the other became Buller and Chivens' first 30-inch telescope. Now it's part of their standard line. And this, again, is used a great deal for photometry, CCD work, and so on. In 1971 or 2, was it, David, we sent 4 expeditions to different places in the world to observe the occultation of Beta Scorpii by Jupiter. And in 1973, we decided we were going to really improve the Einstein effect of bending light around the sun, and picked a site in Chinguetti, Mauritania. In those days, the McDonald flag traveled around the world. And someday I hope that will go to the moon, because someday I think there will be a branch of McDonald Observatory on the moon, and the flag should go with it. So the foundation is there for another 50 years of very, very strong astronomy at McDonald Observatory. What will that future be? Well, the last paper of the program is going to be about the spectroscopic survey telescope and related things. I think there can and will be even more and better research and still more and deeper ties with space activities. But I also predict that there is going to be a 100th anniversary party for McDonald Observatory, and this is going to happen especially if you, friends in Alpine, who have been such wonderful hosts to us at this meeting, if you will do 2 things for us. First, remember this picture, which is a photograph of the United States from a satellite at night showing the self-illumination of the United States. And unfortunately, the Great Lick Observatory overlooking San Jose, San Francisco, the Great Mount Wilson Observatory overlooking Los Angeles, the Great Palomar Observatory overlooking San Diego now, and the Tucson Observatory seeing Tucson, Nogales, and so on growing, and McDonald in the black hole of West Texas. Now, the point is, how long will it remain black? We have ordinances in Jeff Davis County. We hope to get them in surrounding counties to keep the lights down, always shielded, and preferably low-pressure sodium. And I want a verse to be added to what amounts to the state song of Texas. You know, the stars at night are big and bright, deep in the heart of Texas. I want alpinists to start singing and to spread in this part of the state a verse that sounds like this. The skies at night are dark, not bright, deep in the heart of Texas.